Imagine you're riding your dirt bike, you're having a good time, and your motor locks up on your dirt bike. You tear it apart to find out that the cylinder walls have been messed up. You call a machine shop and make an appointment to have it checked out. You take it down thinking it'll be a while, and you bring something to do. It gets done within the hour, and you wonder how it got done so quickly. Well, a way it could have been done so quickly is on a CNC mill like this. Today, I am going to be explaining the steps for pocket milling on the CNC mill, and my name is Knox. The first thing we're going to need to do is get our tools for the job. We got a 1/2 inch end mill, an edge finder, and our 1-inch gauge block. The first thing we're going to want to do is put our edge finder and what we're going to do is go into our MPI mode, and we could set our speed, and S represents the speed. We're going to run about 1200. Usually what an edge finder would be run at. M3 is spindle movement, so the spindle would be moving. The next thing we're going to want to do before starting it is go into our hand jog, and we're going to want to jog our edge finder down to the part. Get it close. We're going to use our Y and our X axes to move the part different ways, you can see here. Once we move our Z down, we can go ahead and close the doors and go back to our MPI mode, and we can enter our speed and spindle movement. We can go ahead and cycle start for that, and we're going to want to hand jog it. There's different increments of speeds here to hand jog it. It just goes from slower to quicker. We're going to want to go slow, and we're going to want to use our Y. We got our X and our Y and our Z depth up and down. In setting this, you want to roughly bring it in and just keep moving it until it breaks off center. As you can see right there, it breaks off center. So we're going to want to go into our offset. In our offset, we got G54, G55. Those are just work offset codes for different chucks or whatnot, different parts to be run. We're going to want a part 0 set in our Y-axis. I already did the X to save time, but once you part 0 set, you're going to want a point 1. Putting a point 1 would mean to go forward half of our edge finder's diameter to find true 0. If we were edge finding at the top of the part, we'd put a negative point 1 in. Once that's set, we can go ahead and push stop, and we can hand jog it, hand jog our Z up. Once this is up, we can go ahead and unscrew these safety to well. And we want to get our 1/2 inch end mill. And we can put it on spindle. Now, before we go through and set everything, we're going to want to hand jog this down. And we're going to use our 1-inch gauge block and put it under here and slowly hand jog it until it just skims the top of our 1-inch gauge block. Okay, got that. We're going to be in our offset, normally be down here. Hit it again, bring you up to here. We're in tool 3, so we want to go to our geometry, make sure we're still in tool 3 and hit tool offset measure. After doing that, you can see the numbers have changed, and because of the 1-inch gauge block, we're going to have to put a -1 inch to bring our end mill flush to the top of the part. Y to accept. Okay, now we got that set. The next thing to do would be to go into our MDI mode and then program converse. And up here you have different things to do. We can engrave, drill, base. We're going to want to check our setup. We got our end mill. We're going to just keep it at high speed still. There's different settings for each. We got carbide, user. That's good. We got to set our tool diameter, which is 1/2 inch. It's already set, and it's a 2 fluted end mill. So our setup is good. Next we want to go into our pocket milling. We got 3 different choices. We got circular, rectangular, and irregular. We're just going to go ahead and do rectangular. We're not using a center drill for this job, so we can just put a 0 in there. End mill, there's different numbers. We're going to want to put the number of where our tool is in, which holder. G54 work offset is what we're going to work in for this. As I said earlier, there's different offsets you can use. Our X start point would mean where to start from this point, or X edge. We're going to go over 1 inch from that edge. Y start point is the same as the X, different value of X. We're going to start up 3 inches from our 0. Our arcane just says which corner we're going to be using our edge from. And our depth of our pocket, it can vary for whatever part you may be doing. We're just going to go 0.250. Incremental depth is how deep it goes at each pass. So for this we're just going to 0.10. Distance in our X value is how far it's going to cut in our X for the pocket. And our Y is the same thing. So we're just going to go 2 in our X and 1 in our Y. After doing the setup, you would hit F4. I've had this problem before, but to check it, you go back into your MDI mode and offset. Make sure that everything is set correctly. Fix this quickly. I'm going to hand jog my PL. I'll go ahead and take one tool out before I put this in tool 4, so that's probably why I'm getting this error. So I'm going to go ahead and I'm going to hit ATC reverse. Go forward. ATC reverse and forward just changes your tools. After setting or changing a tool, you have to bring your C down and redo your offset. So again, I'm going to use my 1-inch gauge block, and I'm going to set my Z height again. Back into the offset. We're going to hit tool offset measure and subtract 1 inch again to be flush on top of the part. We're going to try this again. So go back into our MDI program converse. Still in pocket milling, still in regular. Everything's set. And we're still good.
Go back into your tool setup, Justin.
This is what was set up before.
Change that to an end mill. Okay, now go back into your offset. Go clear over the end. 4-fluted end mill. That should work. Is this still giving you the error? Try out putting it again.
The way this was set up before, Joey interlined for his at the center drill, and I don't know if that's going to change anything, but we can try it. Still getting the code. Normally, what we would do for this job would be to hit F4, and it would output the program to MDI mode, and the program would be written out up here, and it'd give you different codes like M8 is your coolant, and it would set up your speeds and feeds for the job, so you don't have to go through it manually and figure it out yourself. And what it would do, it would just come in here, and from all the information you gave it here, it would just come down each step of a 0.1, and it would mill that square pocket out. And while doing that, you got different tools which would give you different radiuses for the square. On my poster here, I got a couple different examples. They're using a different end mill here. We got small end mill, big end mill. It gives you a different radius, different size pockets, different depths. Got an example here of a type of pocket milling. So you can do that. Pocket milling is just basically used for like jobs that need holes or pockets in parts that don't have it. You can quickly go through it and look at it. The steps going through, you have to make sure you did your setup, make sure you go into your pocket milling and set up everything in your X start point and depth to get the right pocket you want for the job. The purpose of this job is for out in industries. They want certain things, certain pockets, designs. You can do different designs for the job. And that's pocket milling on the CNC mill. Are there any questions?